From NASA's innovative sticky technologies, a world of possibilities unfolds. Smartphone accessories, factory equipment, and future space garbage collectors, its versatility is truly amazing. Geckos can cling to walls thanks to their microscopic hairs called setae at the bottom of their feet. These are rough, can flex independently, and create a contact surface at the macroscopic scale. The stiffness is due to a physical and chemical phenomenon called the van der Waals force that produces a slight electric field in a neutral molecule, ending up in creating a stiffness even in extreme temperature, pressure, and radiation conditions. Researchers at NASA Jet Propulsion Laboratory in Pasadena, California, explored the potential of this adhesiveness for the space program and developed a synthetic setae that mimic the properties of the gecko feet. On Earth, this is limited to only lightweight objects, but in the vacuum of space and no gravity, can be applied to larger objects like a 20-pound cube or a 250-pound person. What is better, the gecko material stays strong after more than 30,000 cycles of turning the stiffness on and off. NASA also continues to investigate the viability of astronaut anchors for use at the International Space Station. These could replace the handrails currently used to enable crew mobility, which sometimes could be a trip hazard. The material could be integrated within the astronauts' uniforms at specific anchor points of the body, like the boots and gloves. However, gecko anchors can also be a practical way to attach clipboards, pictures, and other handheld items at the International Space Station walls. Another use NASA is exploring is for climbing robots in microgravity that can conduct inspections and make repairs on the exteriors of the ISS. Stanford engineers had a different use for this stiffness. Collaborating with NASA JPL, they designed a new robotic creeper that could help remove the debris in space, which is orbiting our planet at speeds up to 70,500 miles per hour and pose a threat to satellites, space vehicles, and the astronauts on board of those vehicles. The Stanford Creeper has the additional advantage of activating and deactivating adhesiveness using tiny fibers at a sticking angle, so they only adhere if you pull in the right direction. If you pull in the other way, they release the whole. Nick Wettels, a researcher in Stanford who worked in the original project, later licensed the technology and founded Perception Robotics. This company later merged with Hungarian and Danish robotic companies, creating OnRobot, which keeps developing the technologies. An example is a gripper with ultrasonic sensor to locate its target and a load sensor to determine the weight. This is used in manufacturing facilities where it can move circuit boards, solar panels, and many other smooth objects more efficiently than traditional grippers. Another success story is Akin Shannon, a salesman that got inspired after a conversation with his uncle, a systems engineer that worked at NASA. Their discussion about the technologies developed at NASA motivated Akin to look at their published research, coming this way across the sticky invention. He explored the options and eventually came up with an accessory for a smartphone. This synthetic stay is fixed to the case, allowing the phone to be attached to surface like a mirror or the back of a plane seat. His flip stick has now sold more than 1 million units. If you liked the information in this video, please don't forget to subscribe.